Hey everybody, so in these notes we're going to continue on with the intro to hypothesis testing. So, continue where we left off. If the null hypothesis is true, then a p-value or a probability value of a hypothesis test is the probability of obtaining a sample mean that is as extreme as the sample mean or x bar that we found in the problem. All right, so what that means is we found our sample mean. It's a certain distance away from the mean that they're claiming. And so this is the probability that we could have found a sample mean that we did. All right. So, for example, if our sample mean was extremely off of the mean that they claimed, then the probability of getting a mean that's really far off like that might be really small. Right? That really small value or really small probability of getting that value, that's what we're calling the p-value. So it's just something that we're going to use in order to test how likely it is that our sample mean was close enough. All right, so to find that p-value, we're going to be using one of three tests. If the alternative hypothesis, which remember that's just h sub a, contains the less than symbol, then the hypothesis test is a left-tailed test. So what that means is if we have our normal distribution right here, and say right here is our sample mean, then this area off to the left, that's our p-value. All right, that's a left-tailed test. If the alternative hypothesis contains the greater than symbol, then the hypothesis test is a right-tailed test. So right-tailed test means if this was our sample mean, then the probability that we're wanting is over here. So that is our p, and this is a right-tailed test. All right, lastly, if the alternative hypothesis contains the not equal to symbol, so if it contains not equal to, then the hypothesis test is a two-tailed test. So a two-tailed test, again, we have our standard normal distribution. If we have our sample mean right there, then it's the area on both tails. All right, so each tail is 1/2 of p, but if you add them together, then they give you p. That's a two-tailed test. So, example 2. In these same examples from earlier, state whether the hypothesis test will be a left-tailed test, a right-tailed, or a two-tailed test. All right, so really quickly, I'm going to go ahead and fill in our null and alternative hypotheses, because we've already found those in example 1. So I'm going to fill those in real quick. All right, so that part's nothing new. It's just what we found in example 1. So for example A, the one about the mean lifetime for a new laptop before it breaks, we just look at our alternative hypothesis. In this case, it is greater than. So greater than was a right-tailed test. Nice and easy. All right, you just look at the greater than, see that it's a right-tailed test. For B, the one about McDonald's stating that it serves more than 65 million customers a day, again, just look at the alternative hypothesis. It's greater than, so it's also going to be a right-tailed test. And then part C, we see that it's not equal to for the alternative hypothesis. So that means it's going to be a two-tailed test. And that's all there is to these, where it's just asking you what kind of test it's going to be. Whenever we get to the next set of notes, though, that is going to be just a step in actually doing this whole process. All right, and keep in mind, we didn't have an example of it here, but if we had one where HA was something like mu is less than, let's say, 50. If we have one that is less than, that would have been a left-tailed test. Again, didn't have one here, but just wanted to mention it. All right, last part of this. Once we find our p-value, that p-value is going to let us make a decision in the hypothesis test. So if p is less than or equal to alpha, which, remember, alpha is just our probability of making a type 1 error, but we just call it the level of significance. All right, so that alpha is the level of significance. So if p is less than or equal to that alpha, then we reject the null hypothesis. If p is greater than alpha, then we fail to reject. That should not say reject. We fail to. And by the time you're seeing these notes, that'll already be fixed. But we fail to reject the null hypothesis if p is greater than alpha. All right. Now, notice I said that we're either rejecting or failing to reject the null hypothesis. But remember, the null hypothesis is not always our claim. All right, our claim can be different than the null hypothesis. So, here is how we interpret what our final decision is. All right, so depending on whether we reject or fail to reject the null hypothesis, and depending what our claim was, whether our claim was the null hypothesis or the alternative hypothesis, then we just match these up to see what we do with the claim. So for example, if our decision was to reject the null hypothesis and our claim was the alternative hypothesis, then we just follow both of those to this right here, and we know that there is enough evidence to support our claim. All right, because if we've rejected the other claim, the null hypothesis, then since the alternative hypothesis is the opposite of that, then we're supporting the claim. All right, but just use this chart to figure out exactly what you should do with the claim. So example 3, we're going to go back to those same 3 examples one more time. Again, I'm going to have it all written down for you with what we found so far. And then we're going to see what happens whenever we either reject the null hypothesis or if we fail to reject the null hypothesis. All right, so let's go ahead and look at the mean lifetime for a new laptop before it breaks being at most 64 months again. So let's take a look at both options we would get to at the end. So if we reject the null hypothesis, well, the null hypothesis was our claim. So if we reject it, we're looking here. All right, so if we reject the null hypothesis, then we say there is enough evidence to reject, if I can spell reject, the claim that, then we just state what the claim actually was. All right, so the mean lifetime of a new laptop is at most 64 months. All right, that's what happens if we reject the null hypothesis. But what if we fail to reject the null hypothesis? Then our claim is still the null hypothesis, but we just look at the bottom one instead. There is not enough evidence to reject the claim. So there is not enough evidence to reject the claim that the mean lifetime of new laptop all the way to the end. All right. So that part is the same in either of them. All right. The only difference is you either say there is enough evidence to reject it or there is not enough evidence to reject it. All right, let's look at B. So this was the McDonald's one, serving more than 65 million customers a day. In this one, our claim was the alternative hypothesis. So if we look at the alternative hypothesis, then when we reject the null, it's going to be the top one. When we fail to reject the null hypothesis, it's going to be the bottom one. So if we reject the null hypothesis, then we say there is enough evidence to support the claim that McDonald's serves more than 65 million customers a day. All right, but what if we do not reject the null hypothesis? So what if we fail to reject the null hypothesis? Then again, just like the first example, it's going to be there is not enough evidence to reject, and the rest is the exact same. Sorry, to support and then the rest is the exact same. So to support the claim that McDonald's serves more than 65 million customers a day, that part's going to all be the exact same. The only difference is this word not. All right, last one. School publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. All right. So for this one, again, the null hypothesis or claim. So it's going to be very similar to A. So if we reject the null hypothesis, then we say there is enough evidence to reject the claim that the proportion of students involved in at least one extracurricular activity is 61%. And again, same as all the others, if we fail to reject the null hypothesis, then it's going to be the exact same, other than we're going to put there is not enough evidence to reject the claim that, and again we're just going to put that exact same claim again. All right, and for the record, normally you would actually write that completely out. Just in this notes, I am kind of running out of space, so you don't have to write it out for the notes, but make sure in homework that you actually write these things out. All right, with that said though, that's it. That's the intro to hypothesis testing. So this is all the basics of it, of how we're just trying to find the probability that we could have gotten a sample statistic that's that far away from the claim, and we're calling that a p-value. We're comparing that to our alpha, which is basically how much error we're willing to have, and then we're stating a conclusion like this. All right, so in the next few sections, our main goal at that point is just to learn how to find that p-value. All right, with that said, that is all. So I will see y'all guys in the next notes. Bye, guys.